The heart of XML technology is XPath, a small expression language for finding XML content. And this presentation is about an attempt to enhance the capabilities of XPath by a new feature. As a starting point, a basic limitation of XPath is discussed, which becomes obvious when distinguishing the operations navigation and search. And my response to this limitation is based on a simple idea. Its elaboration will lead to XPath functions which enable a search for node which is different from conventional navigation. And in particular, it may be powered by XML and non-XML technologies alike. So, on to the problem. What's the problem? Isn't XPath amazing? Its effect verges on alchemy. The sheer existence of XPath transforms any XML documents, and in fact any set of XML documents, into a single space of information ready for navigation. For example, consider this small expression. It searches a whole directory tree for very specific content. It is as if XPath turned my file system into a database. Almost. Because if there are many files, and very large files, then my query works, stops. Out of memory. This is frustrating. The primitive grep command would not let me down like this. The problem? XPath navigation cannot filter documents without parsing them. Before filtering, the documents have to be turned into node trees, and we have a scaling problem. But we are inventive. Consider a little trick. We create a catalog in which the query can look up information about the documents. It's very simple. We just associate the URIs of the documents with information about the documents. Now we can rewrite our query in a way that it does not parse anymore any documents which it does not actually need for further processing. The power of XPath is based on a secret, and this is the modeling of XML items, its documents, elements, attributes, as nodes. A node has a core of information and a surface of node properties, like node name, pointers to the child nodes and to the parent, and so on. And these node properties, they provide the surface along which XQuery navigation rushes. So XQuery navigation is guided by node properties. So XPath excels in navigation, the movement from nodes to nodes guided by node properties. But there is little support for a related operation, node search, which also leads to nodes but does not start with nodes. It starts with a query, information about the nodes of interest. XPath's support for node search is restricted to the functions doc and collection. And this is really a very poor support. So the smartness of XPath is navigation, not search. XPath navigation is based on node properties. Access to node properties requires node construction. So navigation must be preceded by the parsing of the documents. So XPath cannot search for bookings with a red status. All it can do is construct all bookings as a tree, then navigate to that status element and then decide whether it has a red status or not. And in the situation that we want to process a small number of target nodes to be gained by selection from a very large collection of candidates, then we obviously have a scaling problem. XML databases solve this problem by maintaining persistent representations of node trees and indexes, and that's very powerful. But there are also issues involved. First of all, there is a lack of underlying standards. I always think XML databases begin where the standards end. Then there is a lack of portability. There's vendor lock-in. And finally, the closed nature of the technology. I will come back to that later. So, problem understood, goal implied. I would like to complement XPath navigation with a node search which does not require prior node construction and which is portable. I want to be like an eagle, see the nodes I need and seize them. I do not want to be like a chicken which runs along the ground, picking at each node until it finds a grain. A possible solution to this challenge is suggested by our trick. And the gist is to associate the nodes with information describing the nodes, but kept outside of the node. Therefore, this information, which I call the external properties of a node, can be stored and queried without constructing the nodes. And the term node search, I simply redefined to mean filtering nodes by their external, filtering a collection of nodes by their external properties. So the idea is to add to a node a second detached surface of properties. Being detached, it can be queried without constructing the node. A new entity of information, which I call a p-node, associates the external properties with a node descriptor, which is a string enabling the construction of the node should it be needed. It can be URI or some other kind of reference, but it can also be simply the serialized node itself, which is a string. A p-collection is a set of p-nodes which represent a set of XML nodes, but which can be stored and queried without constructing the XML nodes. So the principle of node search is a two-step procedure: filter p-nodes and then resolve the node descriptors of the selected p-nodes to the XML nodes. Note that the data structure of a p-node is very simple. It is just a set of name-value pairs. One pair is the node descriptor, enabling the construction of the node. And the other pairs are the external properties, enabling the filtering and selection of the node. And as p-nodes are just name-value pairs, or sets of name-value pairs, they may be stored, managed and queried by XML and non-XML technologies alike. Therefore, I say node search in this sense is non-XML, not only XML. So much for the idea. Its value depends on its elaboration. The goal of portability requires a seamless integration of node search into XPath. The concept of node search must be phrased in terms of concepts which are cleanly aligned with the data model of XPath, with the XDM. Therefore, I propose a little grammar of concepts. A node search is a pair consisting of a p-collection and a p-filter. A p-collection is a set of p-nodes. A p-node is a pair consisting of a node descriptor and a p-face. A p-face is, first a node descriptor is a string enabling node construction, and a p-face is a set of external properties. An external property is a pair consisting of a name and a sequence of atomic values. A p-filter is a set of p-tests combined by the Boolean operators and, or, and not. And finally, a p-test is a triple consisting of a property name, a comparison operator, and a test value. So what is an external property? Certainly the value is just a sequence of atomic values. Concerning the name, for the time being, I decided to constrain it to be a non-colon name, to keep things simple. The semantics of an external property are utterly unconstrained. So it may be a value extracted from the node, or more generally, it may be the value of an XQuery expression evaluated in the context of the node. But it may also be a value which cannot be derived from node contents. For example, providing contextual information, like the timestamp of node insertion. One more remark, maybe one should change the constraint on names and allow more generally Q names, because this would enable us to bring RDF into play. And I think external properties might be RDF triples, and I would love to explore this possibility in collaboration with colleagues who are better versed in RDF. A p-phase is just the set of external properties which a given node has in the context of a given p collection. So here you see a simple XML representation of a p-phase consisting of two properties, one single-valued and the other multiple-valued. A p-filter is a condition applied to a p-phase. It consists of one or more p-tests combined by the Boolean operators and, or not. And a p-test just compares the value of a single property with a test value. So it has three components: the name of the property, the test value, and a comparison operator like less than, equal, and so forth. And a p-filter can be expressed either as an XML element or as an equivalent query string, which is important for practical purposes. So now we are ready for the node search API. As node search is just the filtering of a p collection by a p filter, we have a single function with two parameters, one identifying the p collection, the other one supplying the filter. And as the filter can be specified either as an XML element or as a string, we have two variants of this function. But at any rate, the function returns the nodes, the XML nodes referenced by the p collection of the selected p nodes. And above, you see a simple example how this then, the use of this new function looks in XPath. So far, so good. But the value of node search based on p collections stands and falls with the ease with which one may create and manage p collections. P collection management must be an integral part of the concept of node search. So a new key concept comes into play, which is a nodal. A nodal is a XML document describing a p collection, and it helps us in dealing with the p collection just as whistles and waddles help us with web services. In fact, collection management is based on a small set of further concepts. So the nodal is a description of a p collection. Then we have a p model, which is a set of rules describing how to construct the p-phase. So a given p collection has its own way of associating its members with external properties, and this is described by the p model of the collection. NCAD is a term, short for NodeCAD, catalog, is a term denoting the artifacts used to actually represent a p collection. So an NCAD could, for example, be a single XML document. It could be a set of relational tables. It could be a NoSQL database collection, and other things too. And finally, the NCAT model is a set of rules specifying how to construct an NCAT using a specific technology. Okay, so the model is a standardized machine-readable description enabling the management and use of a P collection. It supplies the implementation of API functions with everything they need to know about the collection. It has 4 parts describing the collection as a logical entity, providing the P model, characterizing the node descriptor, is it a URI or is it a serialized node or what? And finally, supplying the NCAT model. So how is a P model described? The standard form is a set of triples consisting of a property name, an XQuery expression, and a result type. So you see here, again, a simple XML representation, so what I call the P model descriptor, describing how to or describing that the nodes are associated with 2 external properties, one called status, the other agency, and there are certain XQuery expressions to be used, and the name is the type is also constrained. So now I come to the maybe most important slide of the presentation. P collections can be represented by various technologies. So the question arises, how can implementations be guided in a standardized and unified way? And the solution which I propose is the concept of an NCAT model. For every technology supported, for example, relational database, there is a generic NCAT model specifying in all detail how an NCAT is constructed using this technology. Part of the NCAT model is the schema of a model descriptor. A model descriptor is an element providing all configuration parameters which are finally used to put this into practice in relation to a particular actual collection. A model contains exactly one NCAT model descriptor. It identifies the technology, and as it conforms to the technology model descriptor, XSD, it is guaranteed to provide all required configuration parameters. So far, I have defined 2 NCAT models, one for XML-based NCATs and the other for SQL-based NCATs. And here you see examples of the model descriptors. The NCAT model is the ground on which portability is built. An NCAT model is a unit of conformance enabling portability. When an XQuery processor supports an NCAT model, this means it produces NCATs conforming to the model, and it can filter NCATs conforming to the model. And this means the NCATs are portable. They can be shared by XQuery processors. So now we are ready for the collection management API. It gives us operations for creating and updating and deleting P collections. And note, please, that this API is technology independent. The trick is that every function has a nodal parameter. And this nodal parameter supplies the implementation with everything it needs to know about the collection. It's like a Trojan horse tunneling the technology-related details past the XQuery developer, who is not at all or needs not at all be aware of the technological base on which the collection with which he works is based. So let's take a brief look at this technology hiding. Suppose we have a SQL-based NCAD. So we have written a model using the SQL NCAD model. When I then create such an NCAD, the API function analyzes the P model and translates it into a set of SQL create table statements guided by the model. When I feed documents to my collection, the API function inspects the documents, inspects the P model, constructs the P faces, and translates the P faces into SQL insert commands. And when I filter my collection, the API function translates the filter into SQL select command, and finally resolves the node descriptors of the selected P nodes to XML nodes. A first implementation of these APIs and these concepts is available under GitHub. It's an integral part of a lightweight framework for developing XQuery-based command line applications. In a nutshell, Topic Tools assists you in writing command line applications by code generation and by a rich infrastructure which connects your code to the user input, validating and augmenting it. As I mentioned before, presently 2 NCAT models are supported, XML and SQL. SQL constrained presently to the database MySQL. And I should mention that this framework is 100% XQuery. This means I did not change any processor code, and this implies that working with SQL-based NCADs is only possible when working with an XQuery processor offering extension functions which give us SQL access. Good. So as an author of a Topic Tools based application, there are 3 aspects of the support for P collections. First, of course, your code has access to the APIs described in this presentation. Second, your application inherits a command line interface to the collection management API. This means you do not have to write a single line of code, but nevertheless, your application offers the user the possibility to create and manage P collections to their heart's content. Finally, the framework gives you the possibility via annotations to define user parameters, which can have a variety of types. And one of the types supported is just a node search. And this means your user can supply your application with a filtered collection, which, by the way, he may have created also using the command line interface of your application. Now comes the most difficult part of the presentation. I'm aware of the fact that XML databases offer a node search which is incomparably richer than anything what P collections can offer. So the question, is there any point in P collections? I think there is. First of all, think of the portability. You can change XQuery processors, you can change technologies without adapting your XQuery code. And then think of P collections as a generic framework for leveraging non-XML. This means it is future-friendly. You can add new technologies at any time. And it protects investment. P collections enable the reuse of existing IT infrastructure. I suppose that 90% of the developers work in a environment dominated by relational databases. These, without any costs, can be used at the service of XML. I find it interesting, at least to think about the possibility, could p-collections be a part of standard XPath and XQuery? And I think it could. Besides adding p-nodes as a new entity of information to the XDM, the main change would be the addition of a further component to the dynamic context of XPath and XQuery. We already now have the component available node collections. This is a mapping of strings to sequences of nodes. So what I could imagine adding would be available p collections. This is a mapping of strings to sequences of p nodes. Thank you.
Right, we have time for questions. Anyone? Any questions? Michael down here.
Thanks very much, Hans-Juergen. I think that's very useful and very encouraging as the basis for a way forward. We've been having a lot of debates on the XQuery working group recently about collections, motivated by people who want to make JSON documents first-class objects and want collections to be able to filter collections by media type or by other characteristics. It also seems to relate to the work Norm Walsh was describing in XProc, where documents have external properties as sort of metadata, which potentially could be used to select documents in an XProc context. I think there might be a basis for an eXpath project here to add some functionality via libraries. I don't think we're going to get into the base standards in the short term, but I think there's a lot of potential. Thank you.
Thank you very much.
Any more questions? Right, fascinating stuff, Hans. Thank you very much.
Thank you.